email. You probably need to email John Gein, but his email is Kenneth Gein. He's our assistant principal over AP stuff.
Okay.
So if you email Kenneth Gein, just say, hey, I came from Springdale and my AP account says that. It's probably fine, or it's probably an easy fix, but I don't know.
What is it, Kenneth?
Kenneth.Gein. Instead of green, instead of ours. And if I see him, I'll ask him. But probably should contact you. I tend to tell my students to use your personal emails when you're doing AP project, because once you graduate, you lose access to your email account. So then if you need to reset your password or something to check your AP scores after you graduate, you don't have access to see them. So then you can still get them through the college, but it's a much bigger hassle because it's all getting good weekend. I'm so cold.
Got a jacket on.
I know, I'm gonna have to leave a hoodie or something in here. Yeah. Sorry, our thermostat, you can go turn the thermostat up if you want to, but it doesn't work, so.
Let me use it then.
Where are you going? Masters. Recycling day.
Oh, yeah.
My favorite.
Am I supposed to put the recycling out?
Yeah, that'd be helpful.
Okay, just grab it on your way out then.
Okay. Yeah, way, bro. That's crazy. They're probably still wet too.
Can you fill this out for Theta?
I will.
Thank you.
Good. Did you do this homework? The last part?
I'm not, no.
Okay.
Sorry.
No, you're good. I was just wondering, like, these sentences. Yeah. No.
Turned it up here?
4 years.
What? Yeah.
Yelp is beyond. He was saying that it was, he said that it was affordable for everyone, and the calculator, instead of it, like, see how much I was graduating with, like loans, it said 0 loans, but I would pay $80,000 a year. Yeah, out of my pocket.
Yeah, of course.
Huh?
I didn't know scholarship.
What about it? I just need to Okay. I'll get it back to you before class is over.
And Mr. Chandler,
Thank you.
you stapled these?
No, you do not need to staple them.
I don't.
If you want to staple them, you can, but...
I skipped some.
Oh, are you talking about one that had separate pages?
Yeah, page 1 and 2.
Either have your name on both or staple it, I don't care which one. I thought you meant the 2 assignments. I was happy with
No.
I wrote yesterday in Europe. I think if I just pass out,
If we have our name on both of 8, do we have to staple it?
All right, good morning, guys. There are 2 assignments I'm asking you to turn in. If you didn't put those in Google Classroom this morning, once I opened it up, you need to come give me your hard copies here at the start of class.
Wait, not 10? We don't turn it 10.
Not 10.
Do you want me to staple them together or just have them all separate?
As long as your name's on each page, it's fine. If you want to staple the 2 pages of page 8, you can. It's just up to you. That's just the preference thing. I get it back to you by the end of class.
Thank you. I left mine at home, but I'll turn it 8.
Give me what you got. Okay, last call. Any other assignment 8s or 9s you want full credit for?
Was assignment 10 not due today?
You should have done it, but you didn't get all your questions answered last time. So the first thing we're going to do is I'm going to let you ask questions from me. Do I have a stapler? I do.
Use your eyes.
We're turning a 9 too.
8 and 9. Under. Or under.
Oh, I see that, yeah.
Yep. It'll always be written. Okay, is that it? Am I waiting on anybody else?
Oh my gosh. I'm
Okay. Here's the stapler if you want to staple those two. You don't have to, but you don't have to if you have your name on both. Okay, first thing I'd like to do is, some of you guys asked about turning in assignment 10. And again, it's just that I know you guys were working on assignment 10 at the end of last class, and most people didn't finish assignment 10, so there's a good chance you found a few things that you would like some help on. That's the only reason I didn't have you turn in assignment 10 is just in case you wanted help on a couple of those. So, is there anything from assignment 10 that you would like me to go over with you? I guess while you look at that for just a second, and then I'll ask again. Our plan today is the first handout that you got. One of them is called Types of Discontinuities. So I think you need to number that one if I'm right. I think I didn't number that one for you. That's 12. So we'll talk about the start of that. We actually talked about that a little bit on Wednesday, but I pretty much just showed you one example of each. I need you to actually practice those. Those do show up on the, unfortunately everything we do shows up on the AP exam, but I wouldn't just show you one example and expect you to know it in April. So we're going to do the notes for that. Then I'm going to remind you what we talked about on number 11 with continuity. We already did the notes of that last class, so I will ask you to actually go back and practice the rest of those. Then you can go back and practice the rest of assignment 12. And then you'll have the rest of class for the bigger handout, which is our first unit review. So there's nothing new in there, but it's just a sampling of some of the stuff we've done. Remind you about left and right limits and limits from a table versus limit from a graph, all the things that are likely to show up on our quiz. Just to be clear, our quiz is not next class. So just because I'm giving you the test review today doesn't mean that the quiz is next class. But also, as far as like, is it a quiz or a test? To me, those pretty much mean the same. Most of our assessments first semester will be 50-point assessments, but this first one that will be limits is only going to go in as 20 points. So that's why I sometimes call it a quiz, just because it'll be worth less points. It's just not as important as some of the other stuff that we do. So that is the plan for today. And was there anything from assignment 10 that I can help on? Yeah.
11.
No, assignment 10.
No.
Question 11 on assignment 10. Okay. Is that this one? Okay, that's a good one. All right. If f is a continuous function such that there's a point at 3, 7, there's a point at 3, 7, which of the following statements must be true? So, if the limit as x approaches 3 of f of 3x is supposed to be 9. So, basically what I'm going to do here is I'm going to just think of this as direct substitution. If I plug 3 in for x, this is saying when x is 9, y is 9. Is that true? Is there a point at 9, 9? Maybe. There might be, but it says must be true. We don't know for sure there's a point at 9, 9. So let's not pick choice A. Okay, choice B. If I do direct substitution, this is saying f of 6 is 14. Do I know that there must be a point at 614? So let's not pick B then. Boy, this one, you guys are going to see this in the future. But if I plug this in, I get 0 over 0. That could be, I'm going to have to come back to this one. Hopefully one of these other ones works a little bit better so I don't have to dive so deep into that one. Alright, if I do direct substitution on D, this would be f of 9 equals 49. Am I sure there's a point at 949? Nope, then we better not pick it because it says must. If I plug in a 3 here, this would be f of 3 squared is 49. Well, what is f of 3? Okay, Is 7 squared 49? All right, so that one has to be true then. So, again, even though this isn't exactly a direct substitution question, you can kind of see by doing direct substitution, it makes it a little more obvious if it's true or false. Now, again, this one, I was hoping that it wouldn't be this one just because I didn't want to have to dive deeper here. But you guys can see when you plug in 3, you ended up with 0 over 0. And we know 0 over 0, we have to do other stuff. Unfortunately, nothing we have talked about thus far in calculus lets us deal with that. But we will know what this is talking about when we do derivatives in just a couple weeks. Okay, so that was a good one to ask about. Is there any others from assignment 10? Anything else that if it showed up on the test you would want
Did you do 2A?
some help? Okay, is that this one? Okay. Okay, so again, this whole assignment is about the properties of limits. So basically, add, subtract, multiply, and divide, we talked about, this works as add, subtract, multiply, or divide. So I'm going to do this separately. I'm going to think of this as x approaches 2 of f of 2x minus, because there's a minus sign here, the limit as x approaches 2 of f of x over 2. So we just do them separately and then slap a minus sign in the middle because it says subtract them. So if I do direct substitution here, if I plug a 2 into here, this is really saying f of 4. And what is f of 4 equal to? Yeah, right here. If you plugged in a 4 here, f of 4 is 2. And then minus. Okay, over here, if I plug in a 2, this would be f of 2 over 2, or f of 1. Which one of these would be f of 1 if you did direct substitution to those? Okay, if you plug 1 in here, f of 1 is 6, so I'm putting a 6 in place of that. So your answer comes from 2 minus 6, which should be negative 4. Everybody okay with that one? Okay. Another one or two? Again, I don't mind. I just don't want to waste our time sitting here. What you got?
From 10A,
Uh-huh.
these ways use
On 10A, what?
so like on the key it was the first one and the second one.
It should be both.
Oh, it can be both.
This one needs to be both. You see how there's not a plus or minus here?
Oh, okay.
So that means not the right, not the left, but both. So you would need to plug it into this one for the left limit, which would give you 1/4. And you have to plug it into this one for the right limit, which would give you 2 to the negative 2, which is 1 over 2 to the positive 2, which is 1/4. And since they're the same from the left and the right, you can say that. You really have to plug it into both, though. Plugging it into just one of the two and hoping the other one's the same, you're just tossing a coin whether you did it right or not.
So it's not the same,
Then it would say does not exist. Yeah. When the limit from the left does not equal the limit from the right, it does not exist. In fact, I mean, there's no obligation to put these questions in any order, but this is what we just did in part B and C. B is when you do from the left, and it was 1/4. Question C was from the right, which was 1/4. And really, you've got to be able to do both those things to answer this question. If they're the same, it's 1/4. If they were different, it would be does not exist. Okay, last call. Anything else from this one? Okay. Again, so in theory, I guess I could ask for this one to be picked up, but since you guys already turned in 2 assignments and it's going to take me a few minutes to go through those, I'll probably ask for assignment 10 next class. Okay, so let's look at our new piece today, which is the one of the 2 you picked up, assignment 12. And let me get attendance updated real fast. Assignment 12. There we go. Okay, so this one focuses on types of discontinuity. And again, on Wednesday, I felt like I shared a lot of information with you guys, but just very briefly, I talked about a couple different types. I need you to be a little more familiar with them than what we had just barely talked about. So, of course, continuity, this has come up for a few classes, but continuity just means you've got a nice smooth graph, no sudden breaks in the graph, no sudden holes in the graph. So this is an example of a continuous function, but if you've got a break in the graph, so like if I wanted to know what's x at this value and there is no y value, that's an obvious break in the graph, which we would call discontinuous. Okay, and the three types of discontinuity that you need to know for ours is when you have a hole, like this example over here. When you have a hole, what type of discontinuity did we call that? It was not hole discontinuity. Very good, removable. I did warn you that that's the one that is the hardest to remember because it's not intuitive. We would call that a removable discontinuity. Whether there was a point there, like up here, or not. Doesn't matter if this point's there or not. Okay, and then for this example, we've got a vertical asymptote. Do you remember what type we called that? Good. Goes to infinity, negative infinity. This is referred to as an infinite discontinuity. That's its name. I'm highlighting the names. But just so you know, whole type of discontinuity is the only removable. All the others are referred to as non-removable. But call this type of discontinuity removable, call this type of discontinuity infinite, and call this type of discontinuity, what's it look like it's doing there? Right. This is jump discontinuity. Now, when you've got those pictures, and again, whole type discontinuity is the only removable type, all the others are considered non-removable. By the way, just so you know, you don't have to know this for AB, but there are other types of discontinuity. So those of you that continue on with calculus, there's one called like oscillating discontinuity. So if a function zigzags fast enough back and forth, it can cause a discontinuity and stuff too. So there's a couple other types, but these are the ones that can and will show up on your AP exam. Okay, but what we're mostly going to practice is the algebra behind this, specifically the algebra between these two. There's something that happens in a function that gives you a hole versus a vertical asymptote, or a vertical asymptote versus a hole. And you learned this back in Algebra 2 when you did rational functions, and we reviewed it in pre-calculus when we did rational functions. But now we're not talking about just finding the holes and finding the vertical asymptote equations. We're talking about identifying the types of discontinuity and where they're located. Okay, so what you need to remember, you might jot this out to the side. When you get 0 over 0, this is how a hole is created in a rational function. If the same number makes the numerator and denominator 0, you get a hole. If you have a number other than 0 divided by 0, that's where your vertical asymptotes are going to happen. As you get really close to dividing by 0, it goes to infinity or negative infinity. And I don't think you need to know this one today, but if just the numerator is 0, then the whole fraction is 0, and if the whole fraction is 0, then y equals 0, and if y equals 0, you're talking about x-intercepts. But specifically these two. If you get some number makes you 0 over 0, it's a hole, and we will say it's removable discontinuity there. If we have a number besides 0 divided by 0, that's going to be a vertical asymptote, so we will say there's infinite discontinuity there. Okay, so what we will have to do is we've got to figure out what numbers make the numerator and denominator 0. So that is going to require some factoring sometimes. And if it factors, you can just set each factor equal to 0 to see that there's two numbers that make the numerator 0 and two numbers that make the denominator 0. Okay, so would this rational function have a whole? At x equals what?
2.
Okay, so for us, we need to say there at x equals 2, there is some type of discontinuity. What do we call it when it's a whole? Very good. Make sure you practice saying removable. It is not called whole discontinuity. I really wish it was, because it would be more intuitive, but it's not. Okay, is there any number that makes only the denominator 0? Okay, -5. So -5 is going to create a vertical asymptote, which is what we call an infinite discontinuity, because it's going to infinity and negative infinity. So again, I'm focused on what numbers make the numerator 0 and what numbers make the denominator 0. By the way, I have also seen AP questions on the AB exam where it just straight up asked about vertical asymptotes and horizontal asymptotes. So I'm surprised that they ask that sometimes, because that's not really anything to do with calculus. But we just reviewed how to find vertical asymptotes, and we talked about horizontal asymptotes a couple classes ago. Okay, let's do the same thing for number 2. Are there any numbers that make the numerator 0? Okay, what about the denominator? Okay, good. So that took you a little bit longer. If you think there's only one number that makes the denominator 0, you need to slow down a little bit. This is the difference of two squares. The sum of two squares doesn't factor more, but this is again the difference of two squares. 1 makes the denominator 0, and -1 makes the denominator 0. Don't just throw out numbers that you can see makes the denominator 0. You actually need to solve it algebraically. Okay, so is there a hole in this question? And if so, where? Okay, at -1, because it gives you 0 over 0, and we call that removable discontinuity. And if there's any numbers that make just the denominator 0, not also the numerator, like x equals 1, what would that look like on a graph? Vertical asymptote, and vertical asymptotes are known as infinite discontinuity, because vertical asymptotes go to infinity and negative infinity. Okay, let's do question 4 first, because question 3 is kind of a pain. And question 3 is going to be pretty tough for those of you that skip pre-cal. Okay, but question 4, first off, this isn't a fraction, but you could put it over 1 if you wanted to. What numbers make the numerator 0? Okay, and again, the safer play there is to factor that as the difference of two squares. It's a little easier to see. I'm moving on quickly here, because what numbers make the denominator 0? Okay, so do we have any holes? And we don't have removable discontinuity. Do we have any vertical asymptotes? Then we don't have infinite discontinuity. Don't we know what this graph looks like, though? You guys know what x squared looks like, right? And what's the -1 do? Okay, is that ever discontinuous? Nope. So this guy is always continuous. There is no discontinuity there. Discontinuity is going to occur when you try to divide by 0. back to question 3. This one's going to take a lot more thought. Okay, so just between 0 and 2 pi, we need to figure out where, if anywhere, there would be holes and vertical asymptotes for tangent of 2x. Well, first off, to make this a rational function, tangent is the same as what over what? Good. Sine over cosine. Those of you that skip pre-cal, you need to learn that yesterday. That is one that they require you to know for calculus, tangent sine over cosine. Okay, so now if I want to figure out where does the numerator equal 0, unfortunately this is just not as easy as just straight up algebra. But over here I can say sine of 2x equals 0. I'm going to solve this. So how I tell my pre-calculus students, I guess I'm not teaching pre-calculus this year, but I tell them to pretend like it just says x for a second, going one trip around the unit circle. Where is sine 0? Okay, pi and, oh, that's weird. They shouldn't include both of these, by the way. You know how 0 and 2 pi are coterminal? You really should include 0 or include 2 pi. You shouldn't include both. That's not a great question. Okay, but that's if it was x. So what we would do is we would say, well, it could be at 0 plus this one is pi, an integer pi away. Add 1 pi, add 2 pi, add 3 pi. And this was like a formula to find all of the numbers that make that true. But you need to be careful. I temporarily did sine x equals, because that's how I memorized the unit circle, but I really solved for 2x, not 1x, because it was a 2 there. So divide both sides by 2, and integer multiples of pi over 2 is what makes the numerator 0. So if n is 0, we get 0. If n is 1, we get pi over 2. If we get n is 2, we get pi. If n is 3, we get 3 pi over 2. And if n is 4, I get 2 pi. Now, n could be 5 and 6 and 7 and 8, but why did I stop? Okay, I heard a lot of people. Okay, right, it's not in the domain of this question. Okay, now we got to do the same thing for cosine 2x, but it's really the same thing as this. So if you understood this, it's just basically doing the same. I want to know, when does the denominator equal 0? I temporarily am just going to solve cosine x equals 0 because I memorized that mess from the unit circle. Cosine is 0 when x is pi over 2 plus a pi plus integer multiples of pi. But again, I did this for convenience, but I really have solved for 2x at this point. So I need to divide this by 2, which means all of this needs to be divided by 2. So cosine 2x equals 0 at pi over 4 plus integer multiples of pi over 2. So if I take pi over 4 and add pi over 2, that would be 3 pi over 4. If I add another pi over 2, that would be 5 pi over 4. If I add another pi over 2, that would be 7 pi over 4. Okay, so all of that, so I can figure out if there's holes and vertical asymptotes between 0 and 2 pi. So, is there any holes? How come? Right. So no number makes the numerator and denominator 0 in those values. So there's no holes, which means there's no removable discontinuity. But there are numbers that make just the denominator 0. It's all of these. None of these were in the numerator, because if they're in the numerator, they'd be a hole and they'd be removable. We would have just listed them. But all of these, when x is pi over 4, or 3 pi over 4, or 5 pi over 4, or 7 pi over 4, you've got a number other than 0 divided by 0, which is going to create vertical asymptotes, which means the discontinuity is referred to as infinite. Told you that one was a little more to that one. Let's And I want to just take 1 second here, just because there's so much going on there. I want you to see what we just found. So I graphed the original question that we had changed the sine of 2x over cosine of 2x. And if I graph it, well, first off, your calculator does not do a good job of showing holes, but it does do a good job of showing vertical asymptotes. So notice here's a vertical asymptote at, what did we say that was? This was what, pi over 4? Okay, so notice algebraically we figured out there's an asymptote at pi over 4, and then pi over 2, and 3 pi over 4, and pi. Is that correct? Okay, so there's the visual that backs up the work, the algebra work that we did there. Again, that's a very tough question if you guys skipped pre-cal, because in pre-cal we spend I don't know, 3 or 4 classes on that, including the quiz, doing the questions like that. So, okay, so I do want you to put that one aside for a few minutes. That's the end of the examples on that one. So I would like us all to worry about finishing up assignment 11 first. So find that in your binder. I'm going to do a 30-second review of what we talked about last class. And then I want you to finish assignment 11 first. That way, whatever questions you stumble upon, everybody else should be stumbling upon the same questions. Then backtrack, think about what notes we just took on assignment 12 and practice those questions. And then you can start looking at the unit review and getting some of that under your belt. Okay, so the 30-second review of what we talked about on assignment 11. Assignment 11, we talked about the definition of being continuous. So all year long, you read the directions of the question, almost always it's going to say that such and such function is a continuous function. So what that means is it's got a point at that value, the limit exists at that value, and the limit and the point are the same thing. So if you are asked to figure out if something is continuous or not, you should be trying to use that 3-part definition. If the point's there and the limit exists and the point's equal to the limit, say those 3 things and say it's continuous. If the point's not there, or the limit doesn't exist, or the point doesn't equal the limit, state one of those 3 things and say it's not continuous. You really have to focus your thoughts behind this definition though. Don't try to explain it in words. Don't say that the graph is jumping. Don't say there's a break in the graph. Don't say there's a hole there. You need to refer to these. Don't say there's a hole there. Say the point doesn't exist. If the graph is jumping, don't say the graph's jumping. That's not mathematical. That's a way to describe visually kind of what it looks like, but say the limit doesn't exist. If the point's there and the limit exists, but the point's in the wrong spot, say that this is not true. You've got to focus your thoughts behind the definition so that it sticks. Okay, we talked about types of discontinuity, but we just reviewed that, so I'm going to skip past that real quick. And then we looked at one where you could try to solve for a constant to make sure that it was continuous. So I just plugged in -2 into both of these. And then for these to be continuous, these values need to be the same, so I just set them equal to each other, which gave me an easy equation to solve for k. So you might want to spend another minute or two refreshing yourself on that, but then move forward, please. So I'm going to grade these homeworks and get them put in. I've also got a couple of mu alpha theta forms, so bear with me. Give me 5 or 10 minutes to work on this, and then I will come back and offer to help out on the board. Of course, in the meantime, you guys are welcome to work quietly with your neighbors if you'd like to. And as usual, solutions are up on the website, so you are encouraged to check as you work along.
Do you have the mu alpha theta applications?
I don't,
Okay.
because I don't do mu alpha theta. I just have to do the GPA check.
Okay, thanks.
Plus, I don't think they let people join that don't sign up for AP Classroom.
I didn't want to go through all the steps.
Okay, but they won't order you an AP exam if you don't do it, so.
Would you mind doing mine as well?
Yes.
I'm sorry, I was gonna ask you anyway. But I didn't realize people had already asked you.
It's okay.
Thank you. I'll wait up here so you don't have to walk.
Thank you.
Cause I'm in the back corner. Thank you.
I'm really just scared I'm gonna have to do 100 of these is all.
Yeah.
Y'all didn't do it this way last year, did you?
I was gone when we had to do them, so like I missed the deadline. So I'm actually not sure. I don't think so though. It was like a form.
You still
Thank
need to
you.
fill out the top. Yep.
Yeah, I just want to make sure my name is on there for you.
For number 3 here, the key says that it is continuous. I don't know it's continuous, but it says that it 4 equals 1, the point. But it doesn't say that it's
Well, right here. So x equals 4 is right there.
Oh,
So if you put a 4 in here, 1 to the 4th power is still 1.
okay. Okay.
Okay, before I start passing those back, is there a question or two on this assignment 11 about continuity that I can help with? Yeah, so.
Multiple types like discontinuity on one X line.
There cannot be, no. It only makes sense for them to be one type. Yeah.
How do you find an infinite discontinuity?
How do you find infinite discontinuity? So infinite is when there's going to be a vertical asymptote, which is for numbers that give you division by 0, but not 0 in the numerator. If you get 0 in the numerator and denominator, it's a whole removable. If it's just a denominator, it's a vertical asymptote infinite. So is there a specific one of these that's causing that problem? Or?
Well, I was wondering because on the fourth one, at x equals pi over 2,
Uh-huh.
one of them is 1 over 0, which would be, but I don't know what that would be.
Okay, so 0 over 0, if you want to know what this is, that's the one where we have to do lots of calculus work. Factoring, conjugates, blah, 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 blah. But 0 divided by any other number is 0.
Yes. And the other one's undefined.
Right, and that's what you've got, isn't it?
Yes.
Are you worried about tangent?
Yeah. Tangent on pi over 2.
Yeah, so tangent at pi over 2 would be 1 over 0, which would be some number besides 0 over 0. That's not okay, so that would be undefined.
So for that, I can also that word.
Discontinuity.
Discontinuity.
Or not continuous, you can say that too.
Yeah, would it be, would that be infinite, or would that be, a jump?
Well, the point's not there, so I'd say the point doesn't exist. there's not a point at. Oh, wait.
There is in the other one.
Okay, so I need to look at the whole question to be able to answer this. Okay, so to be continuous at pi over 2, I need to ask myself, is there a point at pi over 2? And here's where it says equal pi over 2, so plugging pi over 2 here. So there is a point there. That's the first part of the definition. You're okay with that? Okay. Second part of the definition, we have to worry about the limit. So the limit as x approaches pi over 2 of this function, well, from the left, we would be plugging that in up here, where x is less than pi over 2, and that would be cosine of pi over 2 is 0. And we've got to test it from the right of pi over 2, which would be right here. And that does not exist. So I would say that the limit, I would say it is continuous, and then because this limit does not exist. The limit from the left has to equal the limit from the right. 0 and does not exist are not the same thing. So
is that jump infinite or whole?
That's a good question, but do we have to answer that on these?
I don't know. I was just curious.
No, you don't have to say the type here.
Oh, okay. Cool.
Yeah. So to answer the rest of that, I'd really have to think about the rest of this graph. I mean, if it's just, like if here's pi over 2, I mean, if it's just this, well, I know the limit's not the same. I'd have to see the rest of the graph to be able to answer the type of discontinuity. I'd have to think about this piece too. But they're just really wanting a yes or no and why. So, yeah.
On the key, it says like jump, but do we have to say like removable if we were like at a test?
You don't. Okay, well, jump is not removable. Jump is not removable.
Oh, yeah.
Only holes are removable. You just need to be familiar with that term, because if it says what type of discontinuity is this, if it's a hole, your answer will be removable. If it's any of the others, it'll either say infinite or jump, something like that. But it won't say non-removable.
So we only have to state like non-removable and infinite if they ask it?
Correct, yeah. They're the non-removable types, but they don't refer to them as non-removable. Okay. Does anybody else have one or two from this assignment 11 yet? Yeah.
Number 5.
Question 5. Okay. For each function, identify the type of each discontinuity and where they occur. Now, so same idea, but this is a piecewise function, so it's probably going to be easier in some parts and more difficult in some parts. What you need to understand about this so that you know why I start writing down what I start writing down, because you don't want to just memorize this process. You want to know why it works. This is continuous, this is continuous, this is continuous, and this is continuous. You can plug in any x values you want to into those 4 things. But when it stops being this function and starts being this function at x equals -2, there might be a break in the graph. And, well, actually it's from here to here, and here to here, and here to here. There could be a break in the graph at 4. If these are not at the same value at x equals 4, then there's a break in the graph. If these are not at the same value at x equals -2, there's a break in the graph. So even though individually they're all continuous, you know, you can have a continuous function here and a continuous function here, But if at this y value, where it stops being this function and starts being this function, if it doesn't have the same y value, then there's a break. If it does have the same y value, then they're continuous. So for that reason, that's why I would set this equal to this. But I really don't care about this guy's y values or this guy's y values, except when they're supposed to be at the same place at the same time. So I really only care about when x equals -2. So we plug that in. I get -2 on the left. Negative, what is that, square root of 6? Yeah, negative square root of 6. Those are not equal. So it's going from -2 to -6 at an instant. So what type of discontinuity would that be? Right, that's a jump. So at x equals -2, there is a jump discontinuity. Okay, but there could be another one. I don't know if these have more than one answer to them. But there might be a break in the graph again at x equals 4 because it stops being this function and starts being this function. So you really should set these two things equal to each other. And you really only care if they're the same value at x equals 4. So let's plug in a 4. 16 minus the square root of 18. Is that the same thing as the natural log of 4? No, very different. Those are not equal. So if it's going from negative square root of 18 before x equals 4 and natural log of 4 after x equals 4, it looks like it's jumping again. I would say at x equals 4, there's another jump discontinuity. So individually, all 4 of those pieces are continuous, but when they're handing off at x equals 2, they were breaking the definition of continuity, and when they were handing off at x equals 4, they were breaking the definition of continuity. Both of those would be jumps, because they're going from one value to another value at an instant. This doesn't make sense. Okay, let me go ahead and take these couple minutes here to pass back some of your homework papers, and then maybe I'll have a few more questions by then. The ones that are supposed to be at the same place. So like how this exists right up to x equals 1, and this exists right after x equals 1. So I would set these two equal to each other and then plug in 1 for x. And then this, and this are all supposed to be here at x equals -1. So I would set this and this equal to each other, plug in -1, and it better get 3. This better be a 3, that's at 3, and that better be a 3. Otherwise, something's not lined up.
Okay.
question of math figures.
My brain is not working. I'm so sorry.
Yeah.
I don't even know how
Oh, I know.
There's also that it necessary, and that there
Now I have your others.
The what? The limits? Okay. Well, some of that's what you're gonna figure out as we go through the year. So, I told you the other two big topics in calculus are derivatives and integration. Both of those are only defined with limits. So, specifically, like, without giving you a whole lesson. You know how, like, if I ask you the slope of this line, you could just count rise over run or something. But in calculus, sometimes we want to know what's the slope of this line. And the answer is, it depends on what your x value is. So what we do is we take 2 points, connect them, do the slope formula. We call this point x and f of x, and we call this, we're going to jump over h units. So if you took these 2 points, this is x, y, this point is at x plus h, and then the y value from that. You okay with where those are coming from? Okay, if you plug these fake numbers into the slope formula, subtract the y's, subtract the x's are going to cancel. You're left with what's called the difference quotient. Did you do pre-cal last year? Do you remember simplifying the difference quotient? You should have done that a few times. But realistically, I don't want to know this slope between 2 random points. I want this second point to be super close to this first point. I want it to be as close as possible so that I can know the slope at this exact instant. So I really want h to be what? What number would I want h to be? Right, you want this second point to be as close to the first point as possible, right? So we can't just plug in 0 for h because we get 0 over 0. So mathematically, our fix to that is we can say, well, what happens as the h approaches 0? What's the limit of that? And then all of a sudden, h isn't exactly 0, it's just approaching 0, and all of a sudden, now we can do all kinds of different things. So, and then you'll see, derivatives have a lot to do with everything, but I would be telling you the whole semester if I fully answered that question. So, I guess if your criticism is that these seem like random skills and just like learning how to answer certain questions, I would agree with you, which is why I'm not a big fan of it. Being able to answer these question types won't help you in 2 months, other than to be able to do these question types on the exam. So, unfortunately. Okay, so here, it approaches negative
Oh, wait,
one.
it's three.
Right, so it looks like you did the limit part. It's approaching negative one from the left and approaching negative one from the right. But at that instant, it's up at 3. So there's a hole there, it's jumping.
So is it supposed
I don't know why.
wait, so how would,
Economics, when.
what would I have to get for it to be continuous?
Okay, so for what X value was that?
Negative
Okay, and the limit was what?
That's economics.
Hi.
That's what I took for each one, that class.
the left side?
Economics for personal.
Well, wasn't the left and the right the same?
Yeah,
But
of
if
the
you just
2x?
take personal finance,
Or the-
that does not count. That doesn't count.
When you plugged it in, they both went to negative 1. Okay.
I
So,
don't know, it doesn't, but it's not.
to the left of this, it goes to negative 1, and to the right of this, it goes to negative 1. But when x equals negative 1, that piece in the middle said at x equals negative 1, y was, what was that, 3 or 5 or something?
Yeah.
3? So this is kind of what it's describing. So you've got a hole there because the point's way up here and the limit's way down there. So I would call it removable at x equals negative 1.
So if I were to get 3 equals.
Yeah, if both of these at 3, it would be continuous. Or if this number changed to negative 1, that said negative 1 instead of 3, then it would be continuous. Because then they would all be the same.
Okay, thanks.
Which goes back to today's meme, daily meme. If your limit from the left and your limit from the right are agreeing at the point, what? All of them are connected, so that's why they're continuous. If they all come together to the same value, it's continuous. What? You don't like that?
I discovered my mistake. I was thinking.
Yeah, this daily meme should make sense to you guys with the definition of continuity. If you don't understand that meme, you may not know the definition yet. No, it's mine. When I mean, I did 2 contests, yeah, whatever my test. Most standard assignments are just about 10. If it's a real short assignment, it might be 5. If it's a real long assignment, it might be 20. But just standard is 10.
All right. Thank you. How do you make it not at, is that what you guys are deeper tell? Yeah, it's not something.
You either go to window, and you can change the numbers of what the,
It was
you're just trying to get it back to the standard.
also
Yeah.
the third one.
If this one was back to
They're not,
standard,
it's
that would be
not
3 to
on.
6.
It's like they have a point up there at 3, but then they don't come together. You said, well, you said this one.
That changes what you're
Is that what you think?
Yeah,
It's off
like
on
I just
the
get that.
No, yeah, because then you got negative 1 because of this one.
I have.
Is that what you're asking?
I guess I should like.
Well, no, because you plug from negative
Oh, yeah.
1 in. Yeah, yeah, just plug negative 1. And then instead of like, once it gets to negative 1, and not 3.
Yes, who wants to do this?
Marianne? Yours is harder to remember because your picture's so much older. Or your picture's so much older than everybody else's.
What's the thing? Just use this one, basics, give what you do. 27. Now, she wrote a bunch of equations on this that are and she took this into the
She also has Flappy Bird, but they made her white memory of it before she took the like Flappy Bird. It is a major change.
Word and okay.
I want to know what it is.
Were you at, were you at it?
For which one? For like setting, and then setting three. Are you supposed to hit two? I don't know what. I don't want to. I mean, some of those are not good. So like, should I just he didn't even do anything. It's like right underneath law.
It is right there. I just didn't see it.
I'm looking at mine, like, what do you mean you can't find it?
I just couldn't find it, you know?
You know what? Oh, I can't do math, that's why I'm getting wrong.
And 20.
Did you get fast? Like a little, yeah. Oh, like the bell. Bell,
Don't know about that.
Oh, I know a lot of these. There's no question. I know a lot.
Third, 105. How much time we got? Okay. Let me offer again. It's been a little bit since I took questions, since I was passing back papers and stuff. Is there anything else you have found from assignment 11 yet that I can help with? Okay. Has anyone made it back to assignment 12? Okay. You've got one I can help with? Oh, not yet. Okay. I guess I'll stay out of your way a little bit longer.
Mr. Dunn, do we just start working on this review, or is that for next, the review?
I would like you to get some of it done.
Okay.
The problem is it's kind of lengthy, and so if you don't have any of it done when you come to class next Wednesday, then you need to finish it, find out what questions you have, and do it in time to get your questions answered, which is a lot to do. That's why it helps if you have a chunk of it done, even if it's just the questions you know how to do, just to make sure that you get everything you need done on Thursday, Wednesday.
But you're already done with 12, 11, 12?
No, I was just wondering.
Oh.
So since it approaches the same way, I mean, I don't. So it's like. Oh, no, yeah.
Yeah, just do, this. Yeah.
And then it goes from like minus 2, like really low number, and it jumps up. Negative 4. Or when you go to negative 4, it jumps down.
Well, pick one of the questions you want, because you probably don't need to be looking at those. So if you only care about -4 from the left, you could care less about when x is 2, or even bigger than -4. You're just caring about here to here. You can see that it doesn't have to exist here, but if this is what it is at -4.001, then it's probably approaching, it could be 0. I would probably guess 2/3. That's at 2/3, and -4 is almost the same thing, so it's probably going to 2/3. This 0.666 is almost 2/3. And that's why I would say estimate, because there's no way to know 100%, so. If you said 5 on the test, that's not a good estimate. There's no reason to think it's 5, but 2/3 is fine. Okay? Okay.
This, right? That way it's just
Okay. And then you plug in your line. Okay.
So
That's good. You got it.
oh wait, it's negative 10.
Yeah, you got it. I'm not saying that you will never have to use quadratic formula in here, but it's very, very rare. If it doesn't factor when you're trying to solve it, it's probably one of those factors. Go on. If the point exists, but it's not in the right spot, it would be known as a removed. Yeah, whether it's totally missing or it's not here, but it's somewhere else, that would, all that's still removed.
But the first unit was only chemistry, there wasn't a whole thing.
Okay.
Still wasn't chemistry.
This new?
I don't know. I don't even do the next book. I don't know.
This looks nice and clean.
I think I had it since when I was take the picture of it to like that.
Not like this. Drop it.
It's like there's like and there's like no due dates on it. So it's like, I don't know. That's so bad.
Well, the good thing is that it doesn't matter.
Oh, yes.
I'll make sure fix them now.
Brackets.
Let's hope that it doesn't get worse.
I had a driver do that last year when I had to teach people that. And now
Did we do the sock puzzle last time?
yes.
All right, guys, we've got about 6 minutes here. So let's finish up, find a stopping place for class today. So for homework, if you did not finish 11 in class, which I think you probably should have, I need you to do that. Most of you, I think we're starting to move on to assignment 12. I need you to finish that. And then 13 is the bigger packet, which is the test review. You don't have to do all of the test review before I see you next Wednesday. But you need to understand that in class on Wednesday, I'll give you some time to finish it and some time to ask questions. If you come to class on Wednesday with none of it finished, you're not going to finish it all, figure out what questions you have, and do that in a time that I can help you before you have to leave. So how much of the test review you do before Wednesday should be directly proportional to how well you think you would do on the test right now. If you think you would come close to acing the test right now, you can probably get away with doing a little bit less as a test review. If you feel like you would make it 50 if you took the quiz right now, you probably should do more of the test review so that you've got more class time for questions and more class time to study next week when I see you next. So just to be clear, our quiz is not next class, it'll be the class after that, but that's where you need to move forward. Okay, also, so today I do not have a puzzle for you, but I do have a puzzle-ish activity, but I need 2 people that know how to solve Rubik's Cubes. 2 volunteers for Rubik's Cubes. 1, 2, okay. I saw your 2 hands first. So come to the front of the room, back to back, so y'all can't cheat. Now, how confident are y'all that y'all can do it quickly?
I can do it quickly.
Not quickly? Not quickly, okay. Front of the room, back to back. Okay, it's gonna be a race. All right, raise your hand if you think who's gonna win. Okay, do you think he's gonna win? Raise your hand. All right, very well. Ready? Okay, set, go. Good luck.
This kind of really scary. Yeah, you by 3.
No, you give me that. You gave me that like 3 years ago.
There's no way you're able to.
Not 3 years ago.
You said you could do it.
Can you solve this?
You solved it like a 3 by 3.
That one?
Double extra stuff.
Can I solve that? No.
There's 2 extra steps.
I used to be able to do
Like
Rubik's.
this, this would
If you memorize this stuff. Huh?
It's like it has a lot of.
Have you ever seen people that like juggle 3 and solve them while they're juggling them?
I did.
Me too.
I don't remember.
You're not making much progress there. You're good sport. I just maybe she'll trade with you. It sounds like she's speeding up already.
No. Great.
Did she get 3 by 3?
Yes. I mean, no.
Can I give someone else a go?
Sure, sure.
Any takers? I give up.
There you go. For being a good sport. Thank you. He had his was a little bit harder.
It's a lot better than I would have.